Hey everyone, and welcome to Mike Likes Robots. Today we're going to connect a ROS2 robot, that is our EC2 instance. We're going to connect it to IoT Core using shadows. If you've not seen my video on IoT Shadows, take a look at the link at the top or in the description. That'll explain what's going on. But essentially a shadow is a shared JSON document that you can use to send data up to the cloud or send commands back down. We're going to be using it to understand commands from the cloud. So let's take a look. How do we get started? Well, last video I showed you how to create a thing, how to attach a certificate with a policy to it, and how to confirm that data was coming through to IoT Core. That was using an EC2 instance that we installed ROS2 on. We're going to be continuing that today. We'll use the same repository, linked in the description below, and we'll be following the next set of instructions to create a shadow for it and to start using commands sent through the shadow. So here are our instructions. This is where we left off. We confirmed that the data was coming through correctly. Now we're going to be setting up this architecture today. Essentially, instead of two ROS nodes, one producing fake data and one sending that data to the cloud, we're now going to have three nodes, one producing fake data, one listening to that data, and one sending data to and from the shadow in the cloud. So we've got one more node to consider. So let's start executing some of these commands. Now to begin with, we do have a lot of the environment variables that we had last time, and that's because we saved them in our bash RC. Now remember, this is used on every terminal session, but just in case, if we change something in it, we can resource the file to make sure we still have those environment variables. And we can check by echoing one and seeing if it comes through with a value. And that's coming through correctly. So we should be set up to continue where we left off last time. So let's take a look. First, we're going to create a new shadow name. I'm going to rename it to test ROS2 shadow to match test ROS2 thing. And then we'll use this command just as it gives us. Except that's not working because we didn't source our bash RC. Let's try that again. And that's created a new shadow. So let's take a look in the console and check that that's worked correctly. So here we are in the IoT console. We're going to open up our devices, find our thing, test ROS2 thing, and check the device shadows tab. And there we have test ROS2 shadow ready to go. Now, if we were going to do the same operation using the console, we can go to our things, test ROS2 thing console, open the device shadows tab, and create a shadow. And here we are using a named shadow, which we're going to be calling test ROS2 shadow console. That creates our shadow. Only this one has some fields in, so we're going to edit it to wipe those fields out. If you want to delete a field from a shadow, type that it's null. Then when you save that, it empties the state out. Okay, back to our instructions. Now we need to update our policy. That's because our policy is intended for MQTT topics, but it doesn't do anything about shadows. So we need to update it to allow our shadows to be possible to write to and to subscribe to. That's what this policy is. So we're going to do a similar thing to earlier with the earlier policy file, where we're going to copy the template and update the fields within it. I'm going to copy these variables into the bash RC, source it again, that policy name is fine. And then this set of steps is copying the template and updating it with our new values. So let's take a look at that file before we carry on. Here is our shadow policy.json, and you can see that our account ID has been inserted, our region has been inserted, and our shadow name has been inserted. Oh, sorry, our thing name and our shadow name, they've both been inserted. So now we're allowed to subscribe to updates to the shadow, and we're allowed to receive updates to the shadow and publish updates to the shadow. We can accomplish this as well by going to our thing, opening up the certificate and the policy inside it. Never mind, opening up our thing and attaching a policy. And we're going to, never mind. So we can do the same thing through the console by creating the policy directly. So let's do that. We can accomplish this as well in the console by accessing the console here, accessing the policies under security and creating the policy. We'll call it ROS2 Shadow Policy Console, and instead of using the builder to build it, we'll copy in the JSON from the file that we've already created. So we can create this, there it is, and now we can try and attach it to the certificate that we're using to connect to our thing. So we go into the certificate, we attach the policy, and we choose our new policy console. That's set up. So now let's do the same thing using the CLI. These commands accomplish the same thing using the CLI, which is a bit quicker if you have it handy. So let's execute those. And we can see the CLI has given us a return similar to before, where it prints out the policy. And we can check it's worked by going to our thing, clicking on our thing, selecting the certificate, and there's our new policy attached. And if we open this up, we'll see it's got the same fields as we just created from the file. So that is our setup complete as far as creating a shadow and giving ourselves the permissions to use it. So now what we're going to do is test it out by running the ROS2 nodes. Now we're using a different command here. Instead of opening 2 terminals and launching 1 node per terminal, instead we're using a launch file, which is a ROS2 concept that allows you to launch multiple nodes at the same time using the same terminal. So let's take a look at this file and see if we can understand what's going on. This is the crack safe file that we're launching. You can see at the top that it's got 2 arguments. There's the path for the configuration file, the IoT config file that we want to use and we were using last time, and the shadow name, which has a default but will override it using environment variables. With those arguments, it will launch 3 nodes. That's the digit generator, the safecracker, and the IoT Shadow node. And these are the same nodes that we've already seen here: digit generator, safecracker, and shadow node. So that's how we can launch it. Let's give it a go. And it seems to be printing out a bunch of stuff. So let's take a look in the cloud and see what's happening. To access the shadow, we go into the core console, list our things, click our thing, and you can see the activity tab going a bit wild here. And then if we open the device shadows tab and click on our shadow, we can take a look at the document. So what's happening is that the digit generator is changing our desired digit every few seconds. And then our safecracker bot is receiving that desired digit and spinning the dial on the safe the other way. So it's switching from clockwise to anti-clockwise for every new desired digit to crack that old style safe. So we can see the example working. So we've seen it working. We've seen 2 ROS2 nodes communicating with each other through a shadow that's synchronized with the cloud. Now we're going to extend that by adding a new state field into the shadow, where if it's enabled, the safecracker will respond to the requested digit, and if it's disabled, the safecracker will ignore the requested digit. The cloud will be able to set whether it's enabled or disabled. So let's take a look. So we're here in the safecracker code, and it's where we're going to start reading the new state field and setting it into the shadow. So what we're going to do is create a new class variable to track our state. And we'll set it to disabled by default. Then we want to know whether to change our state based on a shadow update, which is in this onShadow update handler function. So what we're going to do is load the JSON, log it out, and then here the desired digit is read out. So we're going to add a line here to read the state as well. And again, we're going to set the default to disabled. Now what this line does is it reads the state, but if the state field doesn't exist, it assumes that it's disabled. So it gives us the state field if it exists or disabled if it doesn't. Then we want to check if the desired state is the same as our current state. And if it's different, then we want to change that in our class, in our safecracker, and update the shadow as well. That updates our state, and then we want to publish the change state into the shadow. Now this is the code that does it for the desired digit, so we're just going to copy this and modify it. That should be all we need to receive the new state and to update the shadow with it. So we just have one more part to do, which is to check whether we're enabled or not before starting to respond to the digit. So if we're not set to enabled, immediately return, which just makes us ignore this handler function and not update anything. So let's try running this. First we'll rebuild it and then we'll run the code. And our code is built, so let's try it out. We'll run the previous launch file and take a look at what's happening in the shadow. So we can see that the desired digit is still being updated every few seconds, but the reported digit isn't moving at all. And that's because we set the default state to be disabled on startup, and we haven't coded it to set its state in the reported field on startup. So our safecracker is currently disabled. Let's see if we can enable it. And immediately the reported state also comes back as enabled and has started responding to the desired digit requests. So that's our safecracker enabled again. Let's do one more test where we disable it once more. Ooh. Oops, if we spell it right. And the safecracker becomes disabled and has stopped responding to our desired digit. So that's it. We have a new state field where we can remotely enable or disable our robot from doing something. So we took our previous example and extended it to have a shadow, created a shadow both by CLI and in the console, and attached the necessary policies to use the shadow. Then we ran the example and saw it working, and then extended it even further by adding a state field to remotely enable or disable the robot. So here's a challenge for you. See if you can replicate adding the state field, and then also see if you can read the state when the node starts up. So if the state is already enabled, the safecracker will immediately start up and start working. If you're looking for ways to get more out of your robot, the cloud is a great way to do that. and I've got other videos on the channel that can help you in doing that. So take a look, let me know what you think, and I'll see you in the next one.